Today we have discussed about applications of uniform circular motion. Here we have studied about third application, that is vehicle on a banked road surface. So first of all we have to know about the banking of roads. The process of just rising the outer edge over its inner edge through a certain angle, this is called as a banking of road, and the angle made with the horizontal surface, this is called as angle of banking. Here we have discussed about that, just banking of roads. Consider a vehicle. Vehicle म्हणजे एखादा टू व्हीलर असेल, फोर व्हीलर असेल किंवा एखादं व्हेकल गाडी असेल. Consider a vehicle which is moving on a banked road surface. समजा फॉर एक्झाम्पल एखादी व्हेकल आहे जे बँक्ड रोड सरफेस वरती काय होते, मूव्ह होते. बँक्ड रोड सरफेस म्हणजे असा एखादा रोड सरफेस की ज्याच्या एका बाजूचा रोड हा चढता आहे आणि दुसऱ्या बाजूचा कसा आहे, उताराला आहे. त्याला आपण म्हणतो बँकिंग ऑफ रोड्स. सो एखादं व्हेकल आहे, जे व्हेकल बँकिंग ऑफ रोड सरफेसवरून काय होतं, मूव्ह होतं. सो कन्सिडर अ व्हेकल विच इज मूव्हिंग ऑन अ बँक रोड सरफेस such that plate weight mg which is acting in a downward direction. Here normal reaction n which is exactly passing through its vehicle such that it resolves into two components. First of all n cos theta which is vertically upward direction, and the second one is that n sin theta which is acting horizontally direction. Here theta be the angle made with the horizontal surface. So this is the vehicle on a banked road. So what are the forces acting on that vehicle whenever it is moving through banking of roads? So first of all, two forces acting on the vehicles. Two forces acting on the vehicles. First one is that weight mg which is vertically downward direction. This weight mg, you know about that. Weight and mass, these are the different quantities. Weight means mass into acceleration due to gravity, but mass means the amount of matter contains in that body. So therefore weight mg, कुठलीही वस्तू घेतली तर त्या वस्तूला वस्तुमान असतं, त्यालाच आपण म्हणतोय weight mg. आणि हे weight mg कसं ऍक्ट होतं, which is acting vertically downward direction. Second force is that normal reaction n. Normal reaction n. This normal reaction which is exactly balances the weight mg. So therefore here two components, that is first one is that n cos theta and second is that n sin theta. Resolution of the components we have already discussed in 11th standard. हे जे काय resolution of जे काय आहे थीटाचं वगैरे हे आपण ऑलरेडी 11वी मध्ये असताना शिकलेले आहोत. So therefore this theta, here we draw a perpendicular to on that this component, also draw perpendicular on this component, and here we are applying the cos theta, so we get n cos theta. Here we are applying sin theta, so we get n sin theta. This n cos theta which is exactly balances the weight mg, so we have to write the equation is that n cos theta is equal to mg. Here horizontal component, that is n sin theta, which is provides necessary centripetal force, and this centripetal force is mr omega square is equal to m square upon r. You know about that each and every object in the universe which is moving in a circular path due to which provides a necessary centripetal force, and the formula of the centripetal force is that mr omega square is equal to m square upon r. So here two forces. First one is that vertical component n cos theta which provides exactly weight. Another is that horizontal component n sin theta which is provides the necessary centripetal force. So another force is like that is a frictional force. Frictional force between road surface and tires of the car. So therefore dividing equation by equation n cos theta, we can write n sin theta upon n cos theta is equal to, what is value of n sin theta, m v square upon r. Here we have to put the value of m v square upon r. What is the value of n cos theta, that is only mg. So m and m get cancelled to one another, and we can write v square upon rg. So n cancel, here m cancel. Remaining is that v square upon rg. So we know that about sin theta upon cos theta is equal to tan theta. In standard 9th we have studied about the trigonometry, that is sin theta upon cos theta is equal to tan theta. So we can write v square upon rg. This is equation number 1. So therefore angle made with the horizontal surface, that is the angle of banking, is nothing but a theta. So we can write the tan theta is equal to v square upon rg. Here first point is given that most satisfied. आता याचा अर्थ काय होतो मराठीमध्ये, तर अशी व्हेलॉसिटीची व्हॅल्यू की ज्या व्हेलॉसिटीला एखादं व्हेइकल सेफली ड्रिव्हन along that banking of roads. What is the maximum surface speed? So therefore we can write along tan theta is v square upon rg, v square as it is. So rg going to that side and which is multiplied with the tan theta. So therefore we can write v square is equal to rg tan theta. Here we have to find out the most safety speed. So therefore taking square root on both sides, v square is square root काय येणार v आणि rg tan theta चा square root under root rg tan theta. So therefore v is equal to under root rg tan theta, which is the most safety speed of that vehicle which is moving on a banked road surface. So v is equal to velocity of that vehicle is equal to under root r. R means radius of that circular path of that road surface. G means acceleration due to gravity, and tan means its angle. So therefore maximum safety speed of the vehicle which is moving along a horizontal angle of banking of roads. So v is equal to under root rg tan theta. Next point is that banking angle. So banking angle means here we have to find out the angle theta. We know that the equation number first was that tan theta is v square upon rg. So theta as it is, and this tan which is going to the opposite side, so it will be in a denominator. So we can write theta is equal to tan inverse v square upon rg. So theta means banking angle. So theta is equal to tan inverse v square upon rg. This is equation number 3rd. And last formula which is given here, speed limits. In speed limits there are two conditions. First one is that in lower case and second is that in upper case. So what is the lower case, what is upper case? Consider a vehicle such as like that which is moving on a banking road surface. Here are again weight mg which is acting in a downward direction, n cos theta which is acting in a vertically upward direction, n sin theta which is acting also in a horizontal direction, as the same as it is. But here are two center of motion such that the frictional force between tires of the car and road surface such that which is acting in upward direction, that is Fs. Here Fs be the frictional force which is also resolved into two components. First one is that Fs sin theta which is acting vertically upward direction, and second is that Fs cos theta which is acting in horizontal directions. So here banked road at a lower speed limit. So what is the banked road of the vehicle which is a lower speed limit? So here the weight mg which is balanced by two components. First one is that Fs sin theta, and here parallel component, that is n cos theta. This Fs sin theta parallel with the normal component n cos theta, which two provides the necessary weight of that vehicle. So weight mg is equal to Fs sin theta plus n cos theta, equation number 4. Again we know about the centripetal force. What is meant by centripetal force? The force which is acting along the radius and direct towards the center of the circle, it is called as a centripetal force. Centripetal force म्हणजे आपण काय म्हणतो, असा force की जो acting along the radius but directed towards the center of the circle. So here centripetal force is that m v square upon r. So therefore this m v square upon r which is provides horizontal component. First component of normal reaction is that n sin theta. Second component of frictional force is that Fs cos theta. This n cos sin theta and Fs cos theta which are horizontal components. This is the normal reaction component, this is the frictional force component, but both are in opposite direction. So their directions are opposite. So therefore, the necessary centrifugal force will be m square upon r is equal to n sin theta minus fs cos theta. Why here we have to giving negative sign? Because they are opposite in direction. And why they are taken is positive? Because the vectors are in same direction. So it is positive and here it is negative. So again, dividing equation number 5 by equation number 4, we have to write what is equation number 5? M square upon r as it is. What is equation number 4? Mg. Here again m again cancel to one another. What is the value of m square upon r? That is n sin theta minus fs cos theta. What is the value of mg? That is f sin theta plus n cos theta. Here, don't confuse. Here we have to write the values such that fs means frictional force, and we have already studied in lecture that maximum frictional force is equal to mu s. Mu s means coefficient of static friction and means normal reaction. So value of fs we have to put out. Fs means mu s. Fs means mu s. Again fs here, again mu s. So therefore we can write n sin theta as it is minus as it is. What is the value of fs? We have to put mu s cos theta as it is divided by mg m square upon r as it is, m square upon r as it is divided by mg. So therefore what is the value of mg? Fs means mu s sin theta as it is plus n cos theta. So therefore m1 cancel to one another. Here we can write v square upon rg. So therefore here n and again n common. So taking outside in bracket remaining is that sin theta minus mu s cos theta divided by again here n common, in bracket remaining is that mu s sin theta plus cos theta. So therefore v square upon rg, that is the right hand side as it is. So here dividing equation number 6 by cos theta on both sides, we have to write sin theta divided by cos theta minus as it is, mu s as it is, cos theta divided by cos theta upon here n cancel to one another, mu s sin theta as it is divided by cos theta again plus cos theta as it is divided by cos theta. So v square upon rg is equal to we know that about sin theta upon cos theta means tan theta. Sin theta plus upon cos theta means tan theta minus as it is cos theta goes to cancel to one another, remaining is that mu s upon mu s into sin theta upon cos theta, mu s as it is, sin theta upon cos theta as we can written as tan theta and again cos theta upon cos theta 1. या ठिकाणची टर्म फक्त इथं लिहिलेली आहे आणि इकडची टर्म इथं लिहिलेली आहे. छेदामध्ये जी किंमत आहे ती आहे अशी लिहिलेली आहे. सो देयरफॉर v स्क्वेअर ॲज इट इज. आता इथं असणारा जो rg आहे इन डिनोमिनेटर, this rg goes to the opposite side which is going into the numerator. So we can write v square is equal to rg into bracket tan theta minus mu s upon 1 plus mu s tan theta. This is a v square. So here v square is equal to rg into bracket tan theta minus mu s upon 1 plus mu s tan theta. So therefore v is equal to, taking square root on both sides, v square is the square root v and into under root we can write rg into bracket tan theta minus mu s upon 1 plus mu s tan theta. So this is equation number 7. Taking square root on both sides, v square चा square root v आहे, याचा square root under root rg, याचा square root under root मध्ये आहे, ही टर्म लिहिलेली आहे tan theta minus mu s upon 1 plus mu s tan theta. So this is equation number 7. By using this expression we have to find out the maximum safety speed in lower limit, that is v is equal to under root rg into bracket tan theta minus mu s upon 1 plus mu s tan theta. So this is the expression for maximum safety speed of the vehicle which is moving on a blank road surface at its lower speed limit. Okay, काय काय शिकलो आपण, काय काय पाहिलं तर पहिल्यांदा बघितलं आपण बँकिंग रोड म्हणजे काय. काय सांगितलं बँकिंग रोड म्हणजे द प्रोसेस ऑफ raising of its outer edge over its inner edge through a certain angle. This is called as a banking of road. त्यानंतर आपण बघितलं अँगल ऑफ बँकिंग. अँगल ऑफ बँकिंग म्हणजे काय म्हटलं आपण, द अँगल मेड विथ द हॉरिझॉन्टल सरफेस विथ द रोड, इट इज कॉल्ड एज अँगल ऑफ बँकिंग. त्यानंतर आपण त्याचं एक्सप्रेशन बघितलं. या ठिकाणी व्हेकल, consider vehicle which is moving along a bank road surface, so certain forces are acting on them. So first one is that weight mg which is acting vertically downwards. Second is that normal reaction which is resolved into two components. First one is that vertical component n cos theta and horizontal component n sin theta. And here we are taking the equations. N cos theta is mg, n sin theta is mv square upon r. Divide equation number second by first. We can write tan theta is v square upon rj equation number first. Then we have to study about the most safety speed, that is v square is equal to under root rg tan theta. So v is equal to under root rg tan theta. Then we have to find out the banking angle, that is theta is equal to tan inverse v square upon rg. Then we have to study about speed limits at lower speed limit. Upper speed limit next lecture आपण ते पाहणार आहोत. So what is the lower speed limit? Again here mg weight mg balanced by two vertical components, that is n cos theta and fs sin theta. Again this centripetal force which is provided by n sin theta and fs cos theta. So again divide equation 5 by 4, we can write mv square upon r upon again mg. mv square upon r ची व्हॅल्यू आपण इथे लिहिलेली आहे, छेदामध्ये mg ची व्हॅल्यू लिहिलेली आहे आणि त्याच्यामधून n कॉमन काढला, छेदामध्ये परत आपण n कॉमन काढला आणि त्यानंतर n कॅन्सल केला. Divide equation number 6 by cos theta and we can write v square upon rg is equal to tan theta minus ms upon 1 plus ms tan theta. Here we have to find out its speed in lower case. So therefore v square as it is rg goes to opposite side which is in numerator. So v square is equal to rg into bracket tan theta minus ms upon 1 plus ms tan theta. Taking square root of v square, that is v, and square root of this bracket. So we can write v is equal to under root rg into bracket tan theta minus ms upon 1 plus ms tan theta. This is equation number 7. So this is a vehicle on a bank road surface. Finish.